G'day and welcome back to Human Ransource Machine. These episodes are taking longer than I'm anticipating, mostly because there's a lot more complicated programs in this last part. Enough that I don't think I'm going to do these on stream. I'm going to go straight for moving towards end program, and maybe I'll do a bonus episode where I do these. We'll see. Scavenger chain. Cough, cough. Yes, it's getting a little drafty up here. Facilities management has been notified, but we still have work to do. Each pair on the floor contains data and the address of another one of those pairs. A scrambled chain. Each thing is in the inbox is an address of one of the pairs. Outbox for data for that pair, and then follow the chain. The chain ends when you reach a negative address. Repeat until the box is empty. So, what we'll do here then is we start off, we inbox. We then, so let's see, it'll point directly at that thing. Okay, so what we're going to do is we're going to call this I. Okay, we copy from there. We then grab, not copy from, sorry. We copy to I. Then what we want to do is we want to copy from what I is pointing at, outbox it, bump I. If it's negative, go back to start. If it is positive, we want to goes to this bit. We want to copy from not I, we want to copy from what it's pointing at. So I guess actually what we want to do is we want to copy from what I is pointing at again, and then we want to copy that to I. Okay. So we get 23. We grab that, we put it out. We then bump it, we get 10. We put that in here. We check it. Why did I just put that out? Oh, I see why. We don't need this bit. Okay. Otherwise we're just doing the same thing twice. Get A. We get 10. We then put 10 there. We check. We get P. Okay, because this is a linked list. Ape. Okay. Bad. I just got out of bounds. I was hoping to... There's a set of achievements which are for when you get negative things. What I've done wrong here is I've put the check in the wrong spot, actually. Because I want to check what the bound is, or what the pointer is, and if the pointer is negative. Yeah. But, yeah, this is the problem. I don't necessarily pay all the attention I need to. I get that. But I like how simple this program is to follow a linked list. Yeah, we're grabbing a linked list. And the thing about a linked list is it's basically an item and the thing that points to the next item. It's pretty useful to be able to deal with that data structure, but they're pretty slow, as you can see, because rather than being able to iterate along a line, which we've been doing, we have to iterate by first going and checking what the next thing to point at is. So, yeah. Escape. Apes escape. There we go. There we go. We got our 8 and we got our, yep. Because this is introducing a new concept and thus is a relatively easy one. We'll go on to recoordinator. Recoordinator, rather. Okay. Pawn to b6. And check. And mate. Yes, I win again. I find the game is most enjoyable when playing against the best player I know. Me. Each number in the inbox is the address of a tile on the floor. Send to the outbox the coordinates of that tile, column first, row second. For example, an address of 6 has 2, 1. You can ask your boss for more examples. So one of the things I haven't been doing is talking to my boss. Alright, and let's repeat the beginning. This is, what's the secret of being a practically perfect person? Yes, I like to remember the 4 P's. Proper, planning, prevents, problems. And yes, now we know. It's all about the execution. Give me examples. When your inbox is 9-2, your outbox should be 12-3. Oh wait, 1-2, right. And then 0-3. Gotcha. So here we got 12 and 13. So the outbox should be... How do we do this? So 0 is 0, 0, and you return 0 twice. And we got 0 through 4 to allow us to actually get those numbers. So if we have 12, right, that is this position. It is 0, 3. But how do I actually get that number and know what it is? You get your number, and its column is that number divided by 4. Or rather, it's mod 4. So if we get 13, it's, 1. Yes, that's exactly it. So if we go back to our module, copy. Okay. So, what we can actually do, blah blah blah, I don't care. Paste. This is a mod module. However, what we want to do is the inbox value here is 4. But the second value is this one, right? So that gives us, that outputs that here outputs us 1 column. Okay, so then if we take our number and we work out what row it will be in, and what row it will be in is the and in fact no, we can output that. What row it will be in is the number of times you can divide that number by 4. And we've got our first and our second values. So that's already set up. So what we had before was we wanted to copy to 2, sub 1. Then we want to go, if it's negative, we go down, we go away. If it's positive, we go back up to this step. Yes. And then we want to copy from to and outbox. Wait, no, You know what? That's not sensible. I need to actually work out what I'm trying to do. Okay, so I have a divider, and we have a divisor, which is 4. And is always 4. So, what we do is we have our first number, right? And we want to then put that first number into 2 right now, where we're holding it. Why are we doing that? Because we also want a counter, which is this number, right? Okay, well, which is based off this number. So we copy from this, and we copy that number to there. Okay, so that's doing that. Now we get our first number, right? And we subtract our second number from it. If that number is negative, we return our counter, which is 3. And we outbox it. If it is not negative, however, we want to keep going. We want to bump our counter and then, well, sorry, if it's not negative, we want to copy our number 2 here, bump our counter, and then grab our number again. And go back to the subtract. And you just repeat. And then once everything is done, you can go right back to the start. Because we're basically, combining our 2 dividing programs. There we go, that goes out. We copy over it. We got our 0 and our thing. Three, 1. Yep, 7 is indeed 3, 1. So, one thing that will make this slightly faster is copy from 15 to second, goes up here. Because that will only ever need to be initialized once. Now, it's a premature optimization since we haven't actually seen it finish. But on the other hand, the other thing you could actually do is replace every instance of second with that. Right, and yeah, my solution is really inefficient because I've just glommed 2 algorithms onto each other rather than trying to actually optimize. But I'm fine with that. Let's go on to the last level. Sorting floor. Hey, check out this new office. We've really climbed the corporate ladder together. Thank you, my supervising skills are truly adequate. Your skills are pretty good too, whatever it is you do over there. So, are you ready? For each inbox, for each 0 terminated string, sort the contents of the string. So, what does this algorithm do? Okay, so this prints our string out. Cool. Now we need to implement a sort. And the simplest of sorts is a bubble sort. And we've kind of implemented that before. So what you do then with a bubble sort is you start at 0. So what we're going to do is, this is our pointer. Right? We're going to reset that pointer first. So we copy from 24, copy to pointer. So we're pointing at the start of the string. Right? Then I'm also going to set something up. Right? We're actually also going to copy to flag here, which I'm going to actually do by doing this. This is our flag. This lets us know if we haven't made any swaps this time around, which implies that everything is clean. And then we can output the string. And so we also want to initialize our flag. There we go. Everything is initialized. We got the string out. Now we need to go through and we need to sort everything. And this requires a generic thing. Right, we've got where the pointer is pointing at, and the one after where the pointer is pointing at. Which means that we need two things, right? So this is the start. You know what? I really want to move the flag now, but I'm not going to. And this is going to be X, because X is useful. And X doesn't actually need to be initialized here. What we do is we start off and we get X and we set it to a copy of the pointer. So we start off and we actually grab this, right? Which the very first time around we shouldn't really need to do, but from the second time around we'll need to. We've got X, and the reason for doing that is we're then immediately bumping our pointer. So what we're going to do is we're going to compare the first one with the second one. What we now need to do is check to see if what we're comparing it to is 0. So we then need to copy from where that is pointing to, which is, so copy from this, right? If 0, we need to do something, which is, we've reached the end, so we're actually going to need to either go back to the start, which is copy from this. If 0, boom. Right, going right back to the start. But otherwise, we need to actually do our comparison. And what we need to do then is we've got the second value. So we then need to sub X. We need to sub what X is pointing at. And we can then see if negative, so if the second value minus the first value is negative, the first value is bigger. Yes it is. So if it's negative, we need to swap. Otherwise, we want to bump our pointer, copy, bump, go back to this bit. Which means this bit. Yep, good. But if it's... sorry, that's if it is negative. If it's not negative, we need to go back. Boop, boop, boop. There. So if it is negative, we need to swap them. And we need another thing, which I'm gonna call there. Which will be scratch. This is here to allow us to do a swap. Right? So what we've got is we need to copy from copying this number with the other number. So we grab this number. Oh, not this number. We grab this number. It's actually irrelevant which one we start from. We copy that number to here. We then copy that number. We copy that one to where that is. And then we copy from scratch. And we copy that number to we copy that number to what X is pointing at. Now, the last bit, because we've done a swap, we want to bump our flag, so our flag is not 0. And basically if the flag is not 0, we want to reset our flag and go back to the start. So if the flag is 0, yeah. What have I done? This. Right, we're checking our flag. If the flag is 0, we need to do something. But if the flag is not 0, we need to 0 our flag. Which is copy from here. We need to start the whole copy over again. Yeah, if it's not 0, we need to do that. Right, which is go back and reinitialize. Oh, no, we need to reinitialize here. Which is copy from 24, set our flag. Yep. Copy from 24. Copy to here. And then we jump back to here, where we need to reset our pointer. No. Because this resets our pointer. Yeah, no, we don't need to do this. Okay, let's just see. Let's see what we got. Let's see what mistakes I've made. Hey, wait. Oh, right, no. I see why. I got an infinite loop, and my comparison is wrong. What have I done wrong? Right, so firstly, this bit is init. Oh, read string, actually. Read string. Okay. We finish read string and we need to go into our sort. Okay. Now. So I've got my comparison broken at a very basic level. But firstly, there, we're setting things out. Okay, now, we're grabbing this value, we're subtracting that. That means this is a bigger value. Okay, what if we just change this? Copy from here, sub from there. Is that gonna change? Problem is we have to go back to the start each time. 31 is... Yep, okay. We're swapping, we're swapping. We're bubbling. And yes, here's our bit. But that flag being bumped is good. But then why is it being reset? Because we're going back up. This jump here goes back up above what we want. We don't want to reset that bit there. Okay. My F0. Copy from X. X is not the larger number, so I'm not making the right comparison. So I actually need to change this. This bit, where if it's negative, we actually want to do this. And if it's positive, then we go back. That's actually also much more compact. But only because we now need to take this and go back as well. And we need to change these back. Copy from there, sub there. There we go. Yes, yes, okay. So this is our sort finished, which is great, because now we need to write output, which is print. And print is actually pretty straightforward. What we do is we copy from this, we copy to here, and now we go copy from where that points, outbox. Wait, no. If 0, return to the start. Otherwise, we want to outbox and return. Not return. Otherwise, we want to outbox bump this and go back. There we go. Okay, now we bubble through. There we go, and now we're doing human. Going right back to the start. Man. The key thing is that we basically bubble sort bubbles things up. So we check each of these, and if it's bigger, we move it, or if it's smaller, we move it back, right? And you just slowly bubble things through. And the reason for this flag is if any swaps have occurred, we're not sure that the string is in alphabetical order. And once we have no swaps take place, it's done. It's a really simple sorting algorithm. It's not a very good sorting algorithm, but it's a really simple sorting algorithm. It's got really terrible, terrible speed. And it'd be interesting to try and implement something else. But it also doesn't take much memory. We don't have unlimited memory. And it also is very easy to remember. And so here's the really slow part. See this 13? It only goes back once. So a faster way of doing this will be to take this algorithm and then, once we reach the end, run it backwards. And that would allow us to move things a little bit faster. Run it backwards, except you shrink the lengths. But then you also need to store the ends, and it becomes a more complicated thing. And this is okay, right? I'm not after the optimization challenges just yet. That's something for another time. This is my machine working. Slowly. Slowly. 13's still got a ways to travel. In fact, that's one of the other things, right? You can optimize this by, you're guaranteed to, this is already at the top. Like, every time you do an iteration, you know that you've definitely reached the maximum, right? So, the first time, we know that the 87 is the highest number. But then the second time, we know that 83 is the second highest. 73 is the third highest. And so on, right? So if we keep track of where we're up to, along with this flag, we would be able to actually, like, keep track of where the end bit is. Would be able to skip a lot of this. But yeah, here's our final pass through this one. And then we get the single item entry. And if I weren't writing in assembler, some of these would be a lot easier, because so much of this manual looking at a single number thing is just not dealt with this way. See, I was really close to the size challenge. I was terrible on the speed challenge. This one could be optimized in a number of ways for the speed one. For size, it's a bit tricky to work out. But here we go. Here is the end of the program. Here is the end of the game. Year 42. Congratulations. Congratulations.
Valuable instruction follower.
Yes, don't worry, your job is safe. We've replaced you with this electric box.
It's called a computer. It iterates through a list of simple instructions called a program.
It has a small amount of memory to store data while processing, like tiles on the floor.
It has inputs.
And outputs.
This seems pretty heavy-handed.
Instructions can be used together in infinite combinations to compute just about anything you can imagine.
A truly efficient worker that never sleeps.
It's going to change everything.
Please take your things.
Didn't you already have a
Enjoy
robot?
Whatever it is you people do out there. Congratulations.
Okay. What about the robots? But yeah, that was Human Resource Machine. It's fun. I really enjoy solving programming puzzles like that. It wasn't great to play with a headache, and I've been playing it when I should have been doing other things, which is not good. But I certainly had fun. Yeah. There's not really much to say that I haven't already done. Like, if you don't like programming, I really, like, I have some knowledge. I'm not a professional programmer. That's not actually what I do on a day-to-day basis. I can program. This is a hell of a lot lower level than I have ever done myself. But it was a lot of fun. and I'm going to think about some of the problems and maybe come back to them. Yeah, I'm really glad I played it. This was kind of a spur of the moment decision to get to get this game. But yeah, it was good. It was a lot of fun.